Space is silent. Everybody knows that. No air, no sound. Vacuum doesn't carry vibration. That's true. And it's also completely beside the point, because I want to tell you about a sound NASA recorded from space that scientists still argue about. And the first thing I have to tell you is, it isn't a sound at all. Let that sit for a second. It isn't a sound. So what is everyone listening to? Here's what actually happened. Voyager 1, this little machine we threw off the planet back in 1977, has been flying and flying and flying for almost 50 years now. In 2012, it crossed something called the heliopause. That's the edge of the bubble the sun blows around itself with its solar wind, the boundary where the sun's influence stops and true interstellar space begins. Voyager became the first thing we ever built to leave that bubble. And out there in the space between stars, its instruments pick something up. Not with a microphone. Voyager doesn't have ears. It has antennas, two long whiskers sticking out, 50 feet long each, built to sense electric fields. What they picked up was a very faint, very persistent vibration in the plasma, the thin soup of charged particles that fills the space between stars. Now here's the trick, and I want you to really get this because it's the whole key to the mystery. Scientists took that electric field data, which oscillates way too fast for your ear, in a frequency range you could never hear, and they shifted it down, compressed it, like taking a photograph of someone's heartbeat and turning it into a drum beat you can actually feel. Nothing was added, nothing invented, just rescaled. Slowed into a range your ear can catch. And when they did that, when they turned invisible electric oscillations into audible sound, what came out was this eerie, wavering alien whistle, a hum that rises and falls like it's breathing. People heard it and their skin crawled. NASA called it the sound of interstellar space, and it went everywhere online. A sound from beyond our solar system, they said. Nobody can explain it. Well, hold on. Let's slow down, because there are two totally different questions tangled up here, and if you don't pull them apart, you'll never actually understand what's going on. Question 1, how did we turn this into sound? Question 2, what's actually causing it? Those are not the same question, and only one of them is fully answered. So let's do the first one properly, because it's beautiful once you see it. Space isn't empty, not really. It's full of electricity, full of magnetic fields whipping around like invisible ropes, snapping and twisting through the dark. You think of a vacuum as nothing, but it's threaded with charged particles, ions, electrons, all jostling, all creating tiny electric fields that ripple outward. That rippling is a wave, just not a sound wave, it's a plasma wave, an electromagnetic oscillation moving through charged gas instead of air. Now, Voyager's instrument, it's called the plasma wave subsystem, doesn't hear anything. It measures voltage, tiny fluctuations in the electric field as the spacecraft drifts through this thin interstellar plasma. It's recording a graph, basically, a squiggle of numbers, oscillating at a few thousand cycles per second, kilohertz range. Too fast, too specific a range for a human ear tuned to normal conversation. So the scientists on the ground do something clever. They take that squiggle and shift its pitch down, like turning a radio dial, dropping the whole thing an octave or several. They're not changing the shape of the wave. They're not editing the pattern. They're translating it, moving it into a register your biology can actually process. That's it. That's the whole trick. No microphone in space. No literal noise traveling through vacuum. Just real electromagnetic data, mathematically rescaled, so a human being sitting at a desk on Earth can experience what an electric field is doing 400 trillion miles away. And here's the part that gets me every time I think about it. This works. It's not a gimmick. It's not artistic license. The physics underneath is completely real and completely verified. Jupiter's radio emissions, Saturn's rings, Earth's own magnetosphere, we've turned all of it into sound this way, and in every one of those cases we understand pretty thoroughly what's making the wave. Charged particles bouncing along magnetic field lines, plasma density shifting, electrons getting accelerated. It's all documented, modeled, predicted. So that's mechanism, understood, solid ground. Now here's where it stops being solid. Here's where I have to be honest with you, because if I wasn't, I'd just be telling you a nice story instead of doing science. Understanding how we turned the wave into a sound is not the same as understanding why the wave looks the way it does. When Voyager crossed into interstellar space, the plasma density jumped, which made sense. Interstellar plasma is thicker than the thin solar wind inside the heliosphere. Fine. Expected. But then something strange kept happening. The instrument kept picking up these persistent oscillations, waves that shouldn't have been there so consistently, given the models scientists had for what interstellar plasma should be doing that far from any obvious disturbance. Small fluctuations in the fine structure, little wobbles in density and frequency that don't cleanly match up with the theoretical picture of a calm, steady interstellar medium. Now, I want to be very careful here because this is exactly the point where people run off and say, and nobody can explain it, and turn it into a mystery about aliens or hidden messages. It is not that. Let's kill that right now. This is not a signal. It's not communication. Nobody is broadcasting anything. What it is a real gap between the label we've put on this data and the depth of what we've actually explained. We call it interstellar plasma wave emission. That's a name. It tells you which instrument caught it, roughly what physical process is in the ballpark, charged particles oscillating in a magnetic field, way out past the edge of the sun's protection. But naming something is not the same as understanding it. I've said this 100 times in 100 different contexts because it's the single easiest trap in all of science. You give a phenomenon a label, the label sounds official, and suddenly people think the explaining is done. It isn't. The fine structure, why the fluctuations look exactly like they look, why the plasma out there behaves with this particular texture instead of some other texture, that's still an open, active question. Scientists are still pulling it apart, still refining the models, using data that trickles back to Earth, one faint radio signal at a time, at the literal speed of light. From a machine that's now so far away, it takes over 20 hours for its transmission to reach us. 20 hours, one way. Think about that. By the time you hear that whistling hum, you're listening to something that left the spacecraft a full day ago, from a place so remote our best telescopes can barely characterize what's actually out there. So yes, there's a real mystery sitting inside this data, but it's not the mystery people think it is. It's not, what is this eerie signal? We know broadly what it is. The mystery is finer than that, and I think more interesting than that. It's the mystery of the details. It's the gap between we can describe this and we can fully predict and explain every wrinkle of this. And that gap is where real science actually lives, not in the big dramatic unknowns, in the stubborn little unresolved edges of things we mostly understand. Now, let me tell you why I think this matters more than the mystery itself. We built a machine made of aluminum and gold-plated circuitry, and a record player, an actual physical golden record bolted to its side, etched with sounds and images of Earth, greetings in dozens of languages, in case somehow something out there ever finds it. We threw that machine into space in 1977. It flew past Jupiter, past Saturn. It kept going and going, past the edge of everything the sun touches, out into the true dark between stars. And it's still working, still listening, still sending its faint whisper back home, 49 years later, 64,000 miles per hour, farther from Earth than anything human hands have ever built. And what it sends us isn't a message. It's not trying to tell us anything, it's just the raw hum of the universe translated into a key we can hear. And even now, even with every instrument we've thrown at this data, even with the smartest people in plasma physics staring at it for over a decade, there are pieces of it we still can't fully account for. You know what gets me? People hear nobody can explain it, and they want that to mean something spooky, a secret, a hidden hand. But I think the truth is stranger and better than that. The truth is, we understand an enormous amount. We understand the mechanism. We understand the instrument. We understand the broad physics. And there's still a residue left over, a fine, stubborn, honest residue of not quite knowing. And that residue is not a failure of science. It's the growing edge of it. Every real scientist knows this feeling. You get an answer, and the answer hands you 3 new questions. You think you closed the case, and instead you've opened the door into a slightly bigger room. That's not a bug in how discovery works. That is how discovery works. If everything ever came back fully explained, cleanly, with no loose threads, that would almost bother me more. That would mean we'd run out of frontier. So next time somebody tells you they found a sound from space no one can explain, don't let that scare you. And don't let it turn into some easy mystery you close the tab on. Sit with it instead, because what it really means is there's a machine farther from home than anything human, still listening in the dark, still catching the faint electric breath of the space between stars. And there's a piece of what it's hearing that we haven't finished understanding yet.
That's not spooky. That's not proof of anything hidden. That's just the universe, quietly reminding us that it's bigger than our models, older than our instruments, and not finished revealing itself. And if you ask me, that's the most beautiful kind of unexplained there is. Not the kind that needs a conspiracy, the kind that just needs more time and more listening, and people curious enough to keep asking why.